Thank you. And thank you to everyone else for joining me here today. So first, a little bit about me. I'm a product manager and data scientist here at Anaconda, and I work with our development teams to build tools for data scientists. And I joined Anaconda in 2015 as a data science instructor when I've taught courses in Python and data science and scientific computing. And before that, I was at the University of Pittsburgh where I earned a degree in theoretical chemistry and worked for a while at the high performance computing facility. So here's our agenda for today. We'll get a little bit of motivation and history of the Jupyter project. We'll learn how to set up and launch Jupyter Notebook, along with what you can do with Anaconda and why it adds value. We'll learn how to write good notebooks, and we'll spend a little bit of time learning how to use the debugger when things go wrong. So first of all, let's talk about what we mean by a Jupyter Notebook. A Jupyter Notebook is a single document that enables interactive coding mixed with formatted text and multimedia. And we see here in our screenshot an example of a notebook that I've used to build machine learning models. Here in the middle, there is a code cell with a couple of lines of Python code intended to create a plot, which is displayed directly below it. And just above that cell, I've written some explanatory text. We can see here that the text has some formatting capabilities. There's a heading in bold and the text following below it. And so in this notebook, I have all of the code that I use to build the models, the graphs I use to analyze it, and some explanations about what I'm doing and why. And this presentation, this format for doing code and explanatory text has become very popular in the data science community because it makes it a lot easier to share and explain what you're doing. In one document, you have everything that someone needs to know to go through maybe the theoretical background for your models, some motivation and rationale written into the notebook, along with the actual lines of code and the values that it printed at that time. And for all the same reasons, it makes a really good tool when you're teaching programming. And I use it particularly when I'm exploring a new data set or learning to use a new library. And I find the interactive, easy access to the code really powerful for me. So let's get into and talk about how we set up and launch Jupyter Notebook. One of the easiest ways to do that is with the Anaconda distribution available for free from anaconda.com. And what makes this easy is that it comes with over 400 of the most popular data science packages pre-installed. And these are packages that can help you read and process data, including big data, to build machine learning models and to do statistical analyses, and to construct compelling, rich visualizations. And there are many more packages than just a few that I've mentioned here. And the Anaconda distribution is cross-platform. The same tool works on Mac, Linux, and Windows. And when you download and install the Anaconda distribution, the Anaconda Navigator application is a great place to get up and running. This gives you access to all of the applications and all the tools that come with the Anaconda distribution. And you can get to Anaconda Navigator from the Start menu on Windows or the application directory in Mac. And not only can we use Anaconda distribution downloaded to our desktop, but at Anaconda Nucleus, we have a cloud-hosted Jupyter Notebook ready to go without needing a download. You'll have access to 100 megabytes of free storage and the same 400 plus packages that you get when you if you were to download the Anaconda distribution. And not only do you get a live code environment in the browser without a download, you get access through Anaconda Nucleus to even more things like blog posts. This video of this webinar, I believe, will be available later, along with instructor-led on-demand courses and a very active community forum. And all this is available for free at anaconda.cloud. And that's what we're going to start with. So I've logged in to anaconda.cloud, and here at the top nav bar you'll see a link to notebooks, and that'll take us to the Jupyter Notebook platform. And it takes just a few seconds for it to load. And so I have started my Jupyter lab running on Anaconda Nucleus. And here on the left is where all of my notebooks and my data or my text files will be stored. And when I log out or close the browser, all of that data remains. That data survives indefinitely. And we see here that I've used just a little bit of my disk space because we have access to a few sample notebooks in here. So to get started with our Jupyter Notebook, we'll click this Python icon right here in the center. And this is how we start a new notebook file. So a Jupyter Notebook is composed of cells. And what we see here in our notebook is a single cell ready for code. As I said, a Jupyter Notebook mixes code and text. Text is referred to as Markdown, which is the syntax used for formatting. And so we have a single code cell ready to run code, and I can input one or more lines of Python code. So for example, I'll add some code to read data off the web. And so to execute the code, I can type Shift-Enter with this cell highlighted, or this play button to run that whole cell. It'll run both lines of code. So by pressing play, we see here that this cell has now got a little indicator for 1, meaning that the cell has been run, and it was the first one that ran, and we get a new cell ready to accept more code. Now, this first cell didn't print anything, so no output is seen here. But if we were to use a function like head or print or many other kinds of things, we might get output. In this case, head is showing me the first 5 rows of this data set. We can also get plots. So for example, I can create an interactive plot with a tool called hvplot. So if I import the right thing, I can df hvplot, scatter x, mpg, y, horsepower, add a little more flair to this. And this hvplot lets me quickly create interactive visualizations. So by hovering over the point, I can see more information about that automobile. I can zoom in and drag around. And with a little more lines of code, I can create other interactive widgets like pull-down menus and radial buttons and sliders and things. All of that working right here within the Jupyter Notebook. So this is my first Jupyter Notebook here. And right now we've only got code cells. I've got 3 cells that I've executed using Shift-Enter or the play button, And now it's time to go back and add a little more explanation. And so there's a number of buttons here on the right of the highlighted cell. And I'm going to use this plus above to add a new cell above my first one. And I want to add this cell with some text. And so I'm going to switch it from code to markdown. Notice that the little square indicator goes away because this is no longer executing code, and it won't really matter what order I've done things. So we'll say read data from the web. By typing Shift-Enter or pressing play, it'll format that text. And so we can do a little more sophisticated formatting here. Say, for example, I'll add a cell above here, switch it to markdown, and we'll say plot horsepower versus MPG, putting this text in asterisks means that it's going to make it italics. I can create lists, say, with the following extra data fields. And it's got a nice little spell checker. Origin, year, name. And again, Shift-Enter or play will format the text. Now when I press save, I can give this a new name, say my first notebook. And now I've got that notebook saved. I can come back to it. Let's take another look around what's going on the platform here. So we see we have our disk usage indicator, and Jupyter notebooks take up maybe a few megabytes each, even ones with lots of output and visualizations aren't very much bigger than that. So we can have quite a lot of notebooks to fill up our 100 megabyte disk space. You'll see here next to it there's an indicator for my CPU usage. And this is tallying up the total number of CPU seconds I've used today. And I have an allocation of 500 CPU seconds using the fast CPU execution. If I reach my limit for the day, then I can still run code, it just runs a bit slower. Let's see if we can go a little bit more about what this means, because this doesn't mean that the Jupyter notebook can only be open for 500 seconds. It means I have 500 seconds of actually running code. Because just sitting here right now, I'm not actually running code. I've already executed those 3 cells. The results came back, they're displayed, and I'm done with it. And I won't use up more of my time until I start executing more cells. And so what we can do is, try to see how much CPU usage it takes to process maybe a bit more data than this. So this notebook, this DF data frame, is currently using 72 kilobytes of memory. On our Anaconda cloud here, we have access to around 3 gigabytes of memory. So we can read, a couple of million rows of data. So what I'm going to do is duplicate this data frame a few times. And I want to make it quite a bit bigger. I'm going to multiply it by, say, 20,000. And you see here that it takes a little while for that to run. And when code is being executed, a star appears next to the cell that you've executed, and this status indicator goes from empty to filled. And during this time, we are actively using CPU cycles. And so to duplicate this small data frame up to a much larger one, memory usage deep. In this case, just under 8 million rows and over a gigabyte in RAM. Took a few seconds to run. And that's only a few seconds out of my 500. And now that I've got this large data frame, let's try to do some computation on it. Say, let's compute the average miles per gallon in each region where automobiles have been made in this data set. And that, again, was a very little amount of time, even on almost 8 million rows of data. Now, if you find yourself hitting up against the limits of this, maybe you're training a large machine learning model, or you need to store some more disk space, you can always look into the options for upgrading your account. All right. So right now I have one notebook open. I can keep open 10 Jupyter notebooks at any one time. And that's what this kernels indicator means. If I go back through the launcher, I can press the plus here, I can press the plus button here, I can make a new notebook from over here, and I can have 10 of them open at any time. And if I need to make more room, the best thing to do is to close and shut down. And that also has the added advantage of relieving some of the pressure or relieving some of the memory usage. So right now I'm using over a gigabyte of my 3 that I have available. So if I need to read some more data in a different notebook and I'm done with this one, it's a good idea to close and shut down. And then my kernels gets decremented down to 1 of the 10. All right, so that's a quick overview of the Jupyter Notebook platform. And Jupyter Lab works the same way, whether you're in Anaconda Nucleus or using Anaconda distribution on your desktop. And now that we've seen some examples of writing Jupyter Notebooks, I want to talk about how we can make sure that we write good notebooks. And there are some people who aren't always, the biggest fan of a Jupyter notebook. And in some cases, they believe it lends itself to bad practices and can be misleading for what is really going on in a Jupyter notebook. And let's see an example of what they can mean by that. And what happens is Jupyter notebooks, the cells within them can be run out of order. And so we see here that I've got A and B equal 2, and then I reassign A equals 3. But if I decide to delete that cell, I can get to a place where I have my notebook saying A is 2 and B is 2, but A plus B is 5. Let's watch it again. Assign A and B to 2, reassign A equals 3, run those 2 cells, but delete the second one, and fill it back in with A plus B equals 5. Now, if I had done this, say 6 months ago, and I come back today, and I just open the notebook and I see the code and the output, I might scratch my head and say, I have no idea how 2 plus 2 equals 5. But if I look at it closely, we see that it skips from 1 to 3. Whatever happened between 1 and 3 got lost. And so there's no immediate guarantee that a Jupyter notebook means what it says. That the output may not always match all of the previous code that you can see above. Maybe something was run out of order. Maybe somebody ran a cell twice that was incrementing values or deleting values or just deleting whole cells entirely. And so after a while, and I'm certainly have done this to myself a number of times, I'll just run a notebook and work on it and manipulate it and mess with it and then leave it in somewhat of a broken state. And then I come back to it and I have no idea what's going on. And so there's a way that we can work to try to avoid this problem. And the recommendation that I have is to restart and run all cells, periodically, frequently. And this was something I found very useful when I was teaching, more often, where I wanted to make the most readable notebook, and I wanted that notebook to work. Because I wanted to focus on the thing that I was teaching and not on debugging errors that I had introduced because I might have been a little lazy one day. And so from the kernel menu, if you restart and run all cells, it's a good idea that your notebook runs start to finish without an error. And if, as you're working on a notebook and getting it sort of polished and ready to go, or just sort of exploring through some data, it doesn't hurt to run this every once in a while and check that before you finish up, before you maybe submit the notebook as a report or maybe even as a class assignment, or just want to share it with somebody. It's a good idea to restart and run all cells and make sure that it does exactly what you think it does. And that leads us into a topic of reproducibility, that making sure a notebook can run top to bottom is a really good first step in reproducibility, but there are some other pitfalls you might run into. And in some cases, you can create notebooks that only work on Mac and can't run on Windows. And that's what I was doing here. So here in the screenshot, you see that the first cell says today is assigned to exclamation point date. That exclamation point date is not actually Python code. That is actually running a terminal command on the system where it was ran the last time. And so those terminal commands don't always have to be the same between Mac, Linux, and Windows. And so somebody using one system may do this special trick that's available in Jupyter to call out to the system and assign the value back in Python and then just go and run with it. But that may not work for other people. And that leads us into some of the special things that Jupyter can do that are a little bit beyond sort of general Python or even other languages. And these come in what's called Jupyter magics. And so this %conda is instructing the system to try to install packages. And, for some people that is reasonable and convenient. And for other people, they say, I'd rather have something else. I'd rather do the package installation separately and not have it in the notebook. And what I was trying to do here is get a bunch of packages that I needed to be able to access a Postgres database. Again, using more Jupyter magic. So I got more of these % commands where in just 3 lines of Jupyter here, I can read some data from a database and get it into a Python and get it into a pandas data frame. And part of the problem with that is it's not actually running Python the way you think about it. Those % things are not actual Python functions or Python objects. They're only available in the Jupyter notebook. And if I wanted to take this notebook and export it to Python to bring it into some automated system or maybe make a library out of it, a framework or a package, I have to work a little bit harder at translating that from Jupyter to Python. And so magics are very useful and I use them a lot, but I do think carefully whether that's what I really want to be doing and whether the thing that I write is reproducible. As again, I said that we have Jupyter notebooks keep the output of the code and all the images all right in the file. And if you're using revision control, say Git or GitHub, having all of that in the file may be a little bit more challenging to work with. It can be challenging to look at the differences between versions of your file because this extra stuff gets in the way. And it sometimes gets added to the diff in ways that you don't really want to see all the time. And it also adds more to this file size. And so it takes more time to upload them, and Git can sort of struggle with that, and GitHub can struggle with larger files. And so I've gotten in the habit of clearing out the output cells. And this was also very useful in teaching because I wanted people to read the code and to think about what it's going to write and print before it did so. All right, now that we've seen a little bit demonstration and a little bit of background on Jupyter Notebook, I want to cover an important topic about what happens when things go wrong. And for that, we could use Jupyter to actually debug our code and start to peek behind the scenes. So as you're working in Jupyter Notebooks, things are going to go wrong. It could be something that you wrote in your code or something that happened in something you've imported, a Python module that you wrote or something in a third-party package that you've installed. And it can be hard to figure out what's going on. So here in this notebook in the image, I've got two cells. I'm trying to compute the distance between London and New York, just given their latitude and longitude coordinates. And while I can do that for London and New York, something didn't work for Paris and London. And this error message isn't entirely helpful. It says the cosine is not supported. Certainly I didn't run the cosine function here in my notebook. It must be from something else. And these can be challenging to debug, to sort of work out, just sort of reading this output and trying to figure out what's happening. And for that, we can use debugging tricks within Jupyter Notebook to peek behind the scenes to start to understand what was going on when that error occurred. And in a Jupyter Notebook, when we encounter an error, this sort of red text, right after it, in the next cell, if we run %debug, this is one of those Jupyter magics, we'll launch the IPython debugger and we'll get a special prompt just below that cell where we can interact with the code as it was when that error occurred. We can start to peek behind the scenes, look at the functions that we've called, at the modules or the third-party packages. We can start to print variables and read the source code where the error occurred. And so we'll study a little bit and show some examples here in a few minutes. And what we're going to do is show that we can use the debugger to print the value of variables. We can print the source code where that error occurred, and we'll be able to work through a Python code line by line and follow the execution as it goes. And all of that is available with the debugger. We'll do a little bit of demo here in this prompt version with these little short commands. And in Jupyter Lab, we'll see that there's a convenient interface for that as well. And other ways of working with the debugger are thinking about, well, I know that my code worked up to a point and then something got crazy. So my great circle function here was working and I want to be able to follow it through, because just looking at sort of the error message when things went bad didn't give me a whole lot of information. I want to be able to start a little bit earlier and step through. And to do that, we'll set what's called a breakpoint. We'll instruct the Jupyter Notebook to stop execution at a particular point so that we can now print all the variables and go line by line and try to pin down exactly where something went wrong. And so let's see a demo of that in our Jupyter Lab. So I don't need to have this notebook open. I'll just close and halt that. And I've got my notebook here that I want to study along with a little bit of Python code to help. And so this is my notebook for computing distances just given latitude and longitude coordinates. I've got my great circle function here, which helps through the use of this transform module that I also uploaded to convert my coordinates to be able to compute the distance in miles. So I've got my function defined. I'm going to pick up my coordinates. We saw earlier that I can compute the distance between London and New York, but something goes wrong when I try to compute the distance between Paris and London. And this is that same error message. So right away I get an error message and I go and run %debug. Shift enter or press the play button and I land in the IPDB, the IPython debugger console. And one of the first things we can do is just start printing values. You can see here that it's showing me a bit of Python code from my transform py module. And this is the line 13 in that Python file where everything broke. So let's go print some things and see what happened. If I were to print this value lat rad, which is the radian, radian position converted from Cartesian, I see I get a number, 0.85. That seems okay. I can certainly compute the cosine. I can actually just run that code as well. But let's take a look at the other one. P ln rad is not a number. So that's not going to work at all. So there's something wrong, something's going on in my code. By the time I got to here, something didn't happen correctly. And I don't quite have all the information readily available right here to make sense of it. And so it might be easier if I were to start earlier on in my code and work through it line by line. So notice that the debugger is running, and so the status indicator says that the kernel is busy. In this case, it just means that it's waiting for commands, that it's not actually really running a lot of CPU intensive things. It's just gotten itself halted and stuck. So to stop it, we'll press the stop button. I am going to delete that cell and refresh my notebook and start over again. So when we were looking at this error, something is happening at least in this great circle function that I have defined here. And so let's see about using the debugger to go line by line through this whole code. And that's what this little bug icon does here in Jupyter Lab. It'll enable the debugger and give me the opportunity to start to work through the code. And the first thing I want to do is set a breakpoint to instruct Jupyter that when it hits this line to stop code and wait for me to come and do something about it. So just running this first cell doesn't trigger the debugger because that's just defining the function. It hasn't actually run yet. We'll then make the assignments for all of our positions. I know that the London and New York works, so I'm going to skip down and run Paris, London. And instead of running through the code and hitting the error message, it stopped at the breakpoint. It hasn't even run this one function, spherical to Cartesian. And so here over in the debugger pane, I have access to all of the variables available to this function. So this function was called with 2 Python tuples, one for Paris, one for London. And we see here that the values came in correctly. I don't see anything sort of crazy in here. And the first thing that this function wants to do is call the spherical to Cartesian from my transform.py. And if I want to see what's going on and work through this function one line at a time, I'll use this button called step into. It means don't just run the code, go find the function spherical to Cartesian and stop on the first line of the function. So by pressing step into, notice that the source window down here is changed. It's now showing me the source code for the transform py module, the little Python file I have here. And it stopped on the first line of code. All I have right now is this p, the tuple. And to work through line by line, I press the step over button, or the next button. It executes code one line at a time. So it set the latitude, longitude to the values in the tuple. So I've got my floating point numbers here and they look okay. Now we're ready to run yet another function, degrees to radians. And we'll once again call the step into to see what's going on in this function. Because everything seems to look okay out here. When I step into degrees to radians, all of a sudden something looks odd. There is an if statement in here that if the value is between 0 and 40, it's going to return not a number rather than a conversion from degrees to radians. So my value is currently 48.9, and that looks like it's not going to be within those limits. So when I try to step through the function, it's going to compute the if statement, but not go to this line, but skip down to the computation. So that one seems to be going okay. And I can click next again, and it exits the function. Now I've got lat rad here in my variable list. And I'm ready to run the function again. We'll step into it again. And this time the value of 2.3 is given. And at this time it's going to be caught by the if statement. And you're going to return a string, not a number, rather than a floating point value. So I've found my bug. And there's no helpful comment in here. This could be just an oversight. Somebody did something odd when they were writing this function. And once again, we'll just finish this off. If I continue to step over line by line through the code, I've now got lat rad and lon rad. I'm ready to run line 13. Again, I'll step into it. I'll step over it, come back to the notebook and run it one more time, and I get the error message. So I followed my code from start to finish, calling into other modules. I can even call into other open source libraries that I've imported. And I found my bug, and I'm ready to go fix it. So that's here in the transform py. And I'm just going to get rid of these 2 lines of code. Save the Python file. And when I come back to the notebook, I can restart and run all. And that will correctly compute the distances between New York and London and Paris and London. So that's a quick tour of our Jupyter notebook. And notice here that on Anaconda Nucleus, I've only used just a little bit of CPU seconds in the time that we've spent here. So then, to wrap up, the Anaconda distribution provides many of the most popular data science packages pre-installed, whether you're doing that on Anaconda Nucleus or using the installed Anaconda distribution. And it works cross-platform on Mac, Linux, and Windows. And if you're using Anaconda Nucleus, you'll be able to use it on your desktop and mobile devices. And we covered some best practices for writing reproducible notebooks that are easy to read and ensure a high degree of confidence. And we found that we can quickly debug when something goes wrong. So if you work in a team that uses Jupyter Notebooks, you may be interested in our enterprise-grade team notebook platform. With that, administrators can assign specialized roles and permissions within the notebook system. It gives your organization the ability to centralize code and data storage to a single platform and gives you the capability to scale beyond the limitations of your individual machines, whether that's disk space or RAM or fast CPU hardware or even GPU hardware. And if you'd like to learn more, contact sales@anaconda.com. And thank you for your time today.